All right. Today's class is going to be conducted from Discord today. Part of that is just to see how that goes. Part of that is because I think we can do it. That doesn't mean that's how it's going to be done going into the future. But after you watch this video, I want you to sign into the Discord and put your name in the general channel, and that'll be how I collect attendance. And I'll be there to chat with you guys. So today's topic is power series, and what we're talking about is this idea of absolutely versus conditionally convergent. So let's say I have the sum is n equals 1 to infinity of 1 over n, right? We know that this is the harmonic series. We know that it's divergent. We also should know at this point that if I make it be into an alternating series, then that is convergent, right? Because if it alternates, as long as the sequence goes to 0, if it alternates, that means the series goes to 0. Now, if it only converges because of the absolute value, because of the alternating part, for instance, if I put an absolute value around this, that gives me a series that diverges. This is what we're going to be calling conditionally convergent. Whereas if I have, let's say, this sum from n equals 1 to infinity of 1 over n squared, right? That one we know what am I saying? That one converges, right? This one converges by the p-series test. It's n squared. If I put the negative 1 in there to the n, it still converges. So if it doesn't matter if I have the absolute value signs or not, I'm calling that absolutely convergent. And I think you should say it aloud with a lot of conviction. When you just say absolutely convergent, you say absolutely convergent. That's important. Now, let's look at another type of an example where this may play out a little bit. Let's say I have n goes from 1 to infinity of 1 over 5 to the n, x to the n divided by n squared. And I'm gonna say this will converge. So now, by the way, this is a power series. It's a power series because now we've introduced a variable, okay? So I could think of this as some function where I can plug x into that. And if I plug certain values for x in there, it's going to blow up and diverge. And if I plug other values of x in there, it's going to converge. So now let's think about what values would, well, what I want to do is I want to do the ratio test to figure out when does this, so I'm going limit as n goes to infinity of 1 over 5 to the n plus 1 times x to the n plus 1 divided by n plus 1 squared times n squared divided by 1 over 5 to the n times x to the n. Well, if I rearrange these things, I'm going to get 1 over 5 to the n plus 1 over 1 over 5 to the n. I'm going to get n over n plus 1, that whole thing squared, and I'm going to get x to the n plus 1 divided by x to the n. And remember, I'm looking at it as the limit as n goes to infinity. Okay, so as n goes to infinity, this term right there goes to 1. So if I rewrite this, I'm going to have, and hopefully you see that this will be 1/5 on the numerator. This will be x in the numerator. So this equals limit as n goes to infinity of 1 over 5 times x. And that'll converge if I don't really need the limit statement in there, if the absolute value is less than or equal to 1, which means x is between 5 and negative 5. So now, interval of convergence in this case is negative 5 is less than x is less than 5. I'm still not done yet, okay? Because now we have to think, does it converge at 5 and negative 5? And here, there's a lot of times where it's going to be different on each side because of one side alternates in the other. This one, it doesn't matter if it alternates. When you put negative 5 in there, you're going to have an alternating series. When you put 5 in there, you're going to have a non-alternating series. But either one of them are going to simplify to 1 over n squared, which also converges. So these ones are inclusive. And so if I think of a circle, negative 5 to 5, that's the diameter. I could think of what's its radius of convergence. Radius, so you'll see this term too, the radius, and this is just because we haven't added enough things on, we just thought we'd throw one more thing in there for you. I'm sure you'll appreciate that. That's the radius of convergence equals half of the diameter of convergence, which equals 5. The radius is not sensitive to like testing, which if testing the radius of convergence doesn't really matter if there's the less than or equal to signs versus just the less than signs there. The interval of convergence needs you to test those things. I hope that's helpful. I always find like it's very difficult to figure out something to say when I end these things. But peace out, everybody.